Hello and welcome. I'm Bill Wake. We're here starting a new project. We're going to do something for analyzing music, and I'm looking for some sort of tune similarity type measures. I don't know quite where we're all going with this, but I've got some corpus of tunes I want to compare. All right. So one of the questions you might ask is like, how similar are these tunes? So um, this is the March by C.P.E. Bach. I don't know. I'll try and sing it. Bum 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 bum. And this is Plaisir d'amour by Martini. Bum 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 bum, and so on. All right. Now I can say, well, they're not the same tune, but I don't know. Well, one way we can look at this is called Parsons code, and Parsons code takes the melody and analyzes whether it goes up, down, or repeats the note. So the one on the left, it goes up, and then it goes down, and then it goes up, 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 and then down. And the one on the right goes up, 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 and then stays the same. So we can see there's a little similarity in the middle there, that up, up, up kind of phrase. They're not the same distances. It doesn't tell us anything about that. It just gives us some indication. Now, if we had 100 tunes or 1,000 tunes and started comparing them, we'd probably find some of them had similar shapes of melodies. And the name Parsons code comes from a musicologist, Dennis Parsons, who came up with this idea and put it in his book in 1975. I don't know if he invented it, but it's named after him. So his 1975 book listing out a bunch of tunes and their shapes, and you can index them by that, or at least compare them by that. So that's probably the starting point. We'll do something simple like that. And then we're going to go further. Whoops. This one is Deck the Halls. Its name is actually Nos Galen, or its earliest name that I know of. This comes from handyfinch.com. She's been doing, well, Deck the Hall, a comprehensive history. So there's like 35 or more versions listed on the right. And the one on the left is from the first one we have. I won't attempt to sing it, but it's sort of reminiscent of Deck the Halls. It's not really the same. Then the next one on the bottom is one of the later ones. I don't know if it's the 1921 Hefo Deo, maybe. But it's somewhat the same, but this one goes down 3 notes and this one stays the same and then jumps down, and there's differences. We know from tracking it that they kind of started out from the same tunes, but it's not clear. And if you think of Deck the Halls, the fa la la, that wasn't in the original, I don't think. Just one of those things that came in over time. And so among these 36 versions, I would love to know, like, what's the derivation of them? And one of the ways we talk about that in DNA terms anyway, or, biology terms, they have what they call a phylogenetic tree. And you kind of use characteristics or DNA, fingerprints, or whatever to compare a bunch of species, and you build up this diagram based on which things they have in common, and you kind of find, what's the one with the least in common, or nothing, no features, and then you work up your way to build up this kind of tree that tells us, the relationships of things. So animals, fungi, and plants are more closely related than slime molds, according to this theory. Now, it's no guarantee. It's just more of, it gives you a plausible explanation for the evolution of something, but it could be that a feature goes in or out or any of that stuff. There's too much possible in this, but we sort of get some sense of how connected things are, and so yeah, I guess flagellates, if I remember, is like parameciums. Don't they have a little tail? Microsporidia is another little thing. They're different things, and there's some differentiation between them, and we can sort of make a hypothesis about their evolution. And we'd like to do the same thing from the other, from all those versions of that song. So take the 36 versions and find some definition of characteristics they have in common, and kind of rate them together and see if the evolution looks plausible. We'd expect to find the more modern versions up near the leaves, the most complex things. and the simpler versions back in time, we'd be very surprised if it didn't kind of go that way. And we might be able to guess, where did the song evolve? So I'm into old time music a bit, and a lot of the songs came from the British Isles, and they evolved independently once they got to America in the Appalachian Mountains versus in England. You can go back and find the common roots of these old tunes, but the evolution has changed. So I'm interested in that. I've got, I should bring them out. I've got 4 volumes. They're a inch and a half, 2 inches each, and it's just all these old time songs and as many versions as this person could track down of the lyrics and the tunes. And so, like, I think there's 108 versions of Barbara Allen, and just a bunch of these old tunes that evolved. And there's every one of them's different somehow. Sometimes they combine and all that. You just don't know what's going to happen. All right, and then another piece of this project, there's what they call ABC notation. So on the left is sort of standard music notation or common music notation, and it's if you played a piano or any instrument, this is probably fairly common to you. At least Western European kind of outgrowth music. But we see this fiddle tune, "Speed the Plow." I've heard it called "Speed of the Plow" and so on. And I took it from the Tune Archive, where there were at least 6 or 8 versions of this song. Excuse me. And so on the left is standard music notation. On the right is what they call ABC notation. And you have a bunch of metadata. Basically, there are these fields: X:, T:, title, S:, source, maybe. M is meter. I'm not sure. L is what note gets the beat. So you can see it's mostly eighth notes. R is rhythm. It's a reel. Here's a link to it. Here's a transcriber. And the key of G. Okay, 1 sharp is the key of G. And here's the notes. Well, parenthesis 3, D, E, F. That's this, D, E, F. Well, it's F sharp because of the key. Then there's a bar line. Then there's a G for 2 eighth notes and a B for 2 eighth notes, and then D, E, D, B. Okay, corresponds here, another bar line. Notice some of these letters are lowercase and some are uppercase. The lower notes, so D here, the first D in there, corresponds to the low D, the kind of just under the bottom bar there. And the D up here is the lowercase d. And if you go out of that range, there are other indicators on the notes. But for the most part, I'm just writing down the notes: D, E, F, G, B, D, E, D, B, D, E, D, B, D, G, D, B, and so on. Okay. And this notation basically encodes these tunes. And there are hundreds or thousands of old fiddle tunes encoded like this across a few sites. Slipper Hill is one, tuneark.org. There's I forget the name, it's in the UK, and others. I mean, there's at least half a dozen I know I've run across. So my working theory is I want to, I should have written a goal slide here, but I would like to be able to take standard ABC notation and run this song with a bunch of others through some analysis and get information about their connections. It could be this phylogenetic tree. It could just be this. I want to start somewhere and get going and then see what goes. I'm going to get Handy Finch won't be here to help me, but I'm in contact with her, and I will do things that maybe she suggests to try and help with the analysis that goes on. All right. I've got a little bit of background with DNA analysis, and definitely the possibilities seem like they're there, because when we compare DNA strings, you have these operations like, select a slice and repeat it somewhere and delete a slice and so on. Kind of the mutations you can make to DNA or to text, we can make to music. Another thing that's common is repeating stuff. So I don't know. Do we have any in this tune? Yeah, this downward phrase D C sharp or D C B A D C B A bum 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 bum. Okay, the whole first two measures just repeats. Okay, then this measure repeats, then it varies, then it does something else. There's definitely repetition and there's definitely differences. And somehow, identifying those chunks of music that are the same and repeated somewhere, it feels like I should be able to make operations about how to edit one song to the other, and maybe make some judgments on this. Now, these both happen to be in the key of G, but in general, that's not the case. So I might need to do like musical operations like transpose. Let's say this were in D, I would transpose this into the same key as that one and then judge. But for the Parsons code, I don't need to know that. Let's see, that was up. I'm just measuring up or down, and I can do that with what I have. So I think our initial run, I'm not going to do triplets, and I'm not going to do fancy stuff. I'm just going to find the notes like D, E, F, G, B, D, E, D, and I'm going to map them into ups or downs. So I'm going to be doing some filtering on this stuff and go from there. So I think I'll start. My starting point is just going to be, I'm going to take just a string of letters and do the up down thing. I will only worry about uppercase and lowercase. And I won't worry about sharps and flats or any of that stuff. I won't worry about triplets or bar lines or anything. We'll get the letters going, then I'll maybe add the bar lines and maybe maybe we can ignore these. I'd like to get to the point of reading a real file at some point, and we'll see what we can do. All right. I think, yeah, that's it. So let's go to the IDE. All right. All I've done here, I created a new project. I created an empty to-do. Let's say our goal is Parsons code for a simple string. Okay. And I've got the keynote. We have our starter app is just a hello world. I did create an icon and used one of its colors for an accent color, but everything else is the same. Okay. And I think my tests are OS independent for the most part. So I think I'll just make a new test directory with some test files in it and start there. Okay. So let's just run this once, see where we are. And while that's thinking, I think I can create my new folder. Tests, okay. Are we still attaching? Okay. I'll make a new file while I wait. Unit test case class. I forget. I think this is the one John gave us. Okay. Let's just do notes test. Okay, and then we saw the app running. There's tunesim, hello world. Nothing else to it. Can I stretch it? Not even. Okay, so let's quit this. All right, so I have import tunesim. That's the stuff up here. And initial test. And I don't know why they tab these out. Whoops. I'll just take the default tabbing. Okay. So I want to take a string of letters. Let's just start uppercase and convert that to a Parsons code. Okay. So, I don't know, maybe the empty one is easy to start with. It's not so meaningful, but it'll get us something. Empty tune is just star. So you always start with a star, and then from there on up or down. Okay. And, well, I'm going to say, let's see, I guess this is, I don't know, Parsons dot, let's make an object. Parsons dot analyze of nothing let's take assert equal. Okay, and backfill in Parsons equals new Parsons code. Okay, and this shouldn't build. I could take a bigger case, but I think this this gets me there. Build succeeded. I don't believe it. I always forget about this. It doesn't really build. Oh. tunesim iOS. Cannot test. UI tests are not supported on my Mac. Details. Yeah. Okay, I don't want UI tests. Why do you think you're... Maybe this is the problem. Okay, let's just put it here. Class Parsons code. And it has one function. Oh, this is a let. Okay, one function, analyze. And it takes a string of notes and produces a string that's the analysis. Return empty, get us through. And what do we got? Cannot find Parsons. Consecutive statement. Oh, not writing Java this week. Okay. Oh, yeah, I'm really not writing Java. Okay, notes. String. Okay. All right, now let's run it. Test iOS on UI tests are not supported on my Mac. Details. Why does it think it's a UI test? All right, let's go find out. tunesim, tunes, tests. I guess I want to add this to there. Let's see, where's my test schemes? I mean, I'm on my Mac. I should be running these tests. Why am I not? Okay, but this got included over there. All right. don't really need any UI tests. What is going on? Okay. Failed to launch. Well, I don't really care about this. Oh, it's an authorization problem? Okay. That one built. All right, let's try this. Can I add? No. Now, I thought they changed the way these tests did their thing. Product. Schemes. Convert scheme to use test plans. Sure, whatever. Okay. Mac OS, edit test plan. I haven't done very many projects that have everything in them. Test Mac OS. Okay. Add. Oh, it doesn't have a test target. Okay, let's close this. Somehow I need to make this a test target. Okay, test plan, 0 test targets, 1 configuration. Default. Well, I think I want to do that. And then test iOS, I want to turn it in. I lost that option. New test plan. Well, let's see if this works before I go too far. Test plan default, does that run? I should get my failing test. What is running? Manage test plans. Okay. Here's test plan is the default. Let me add the iOS one. TuneSim Mac OS. Tests. I guess that was add other. No, somehow I need to turn this into a test plan. Okay, let's close. What happens if I run this? TuneSim iOS, no. gotta find something. Tests iOS. Huh. Okay, I've got tests. Test plan, XC test plan. Okay. Okay. Automatically include new tests. I don't think I want iOS tests. Oh wait, this is test iOS. I don't think I want note test in here. Oh wait. I want note test, but not these two. Okay. All right. Okay, that's looking better. I don't think I'll need these for a while. These are still under there. Test iOS. There should be a whole new plan. Okay. New test plan. I don't know what I'm doing here. Okay, it's enabled. No tests. Let's add test iOS. No, that was wrong. Test targets. So I don't have a test target apparently. Manage test plans. TuneSim test plan 1 test target. Test plan 0 test targets. Let's add one. Wait. I don't want to spend all day on this. Okay. Test plan, manage test plans. I mean, that's too many. Add a test plan, new test plan, manage test plans. Okay, let's take this out. And this out. Manage schemes. TuneSim Mac iOS. Those seem like good. Okay. Now try and add a scheme for. Nope. Cancel. Auto create schemes. Yeah, you've. Okay. Test plan. Let's go back here. I'm going to delete this. Move it to trash. Now, test iOS. Product. Test plan. New test plan. TuneSim iOS XD test plan. Product scheme. New scheme. Target TuneSim iOS. That's not what I want. I guess I've got to make a new target. Okay, that's back on the project. Target here. Unit testing bundle. I think that'd be a multi-platform thing. That just is not right. Okay, I'm gonna move this for now. See if I can run it in here. Whoa, what's this? Okay, I don't know what happened there. Put my whole system in dark mode. Okay, very weird. We still running? No. Okay, I'm gonna live with it for now. All I want to do is run this. It's failed. This Mac OS. I'm gonna comment this out, or I can. Do I have add ignore? Shoot, there's a way to do it. Oh, it's a manual thing. I'll just do it this way. Okay, macOS launch test. Let's ignore that too. Okay. For a lot of grief for that little result. Okay. Maybe during break I'll fix the colors back to where I usually keep them. Very weird. Okay. And it's still trying to run those. All right. Anyway, I can see here like notes of string and string result. String result might be okay, but notes is definitely going to be an object of some sort. So I mentioned last week in my blog about type def, and this is a case where I might use that. So the tune, or maybe it's notes equals string. So for now I can change the type in my code here, and sorry, type alias. I can use it in here, and it should make things work out okay. So let's do that refactoring, and let's check in. Okay, initial test. The test plan structure is messed up, but we have a test for, we have a first test for Parsons code. Okay, now let's move on to something a little more interesting. And the other thing I can do this on the constructor. Whoops. Notes of this, so I can just emphasize that I am passing a note structure, and that somehow I'm going to, whoops, that goes inside. I may give a string constructor for it eventually, but okay. Let's test. Let's deal with a one note tune. Is just star. Now this one's still going to pass since we've hard-coded star. Okay, should pass. All right. Okay, so, shoot, I don't even have my chat going here. Sorry. If you sent me a message, you'll have to repeat yourself. All right. Okay, now let's get interesting. So, function test, 2 notes going up. Okay, so C to D should be a U. It's going up. Well, they all start with star, so it should be star U. Okay. Let's get this going. Should fail. Okay. Now we need to say, well, let's see. I mean, I think what we're doing, and this may be too string oriented and I've got to switch over to notes, but I think if I take the list of notes and zip it with itself with the first one dropped, then I'll have the first note versus the second note and so on. So if I zip sequence 1, sequence 2, so I'll zip notes with notes.drop first. Okay. And then I will do a map because I'm gonna do something for each pair of those, and what it gives me is first, second, in, and maybe I'll say note 1, note 2. In this, okay, and then if let's see, if note 1 is less than note 2, then well, I guess we're going to return if note 1 less than note 2, then up. Okay. Otherwise, I don't know. All right. And then this is really return star plus this. Okay. I don't need to return since it's the only statement in here. Okay. Zip these two things together. This first one will be CD, the second one will be D. And if note 1 is less than note 2, then we get the ops. All right, so I believe this should pass. Okay, and I guess we're ready to go on to a new test. Let's do 3 notes going up. I think this should already pass. Test 3 notes going up. C, D, F. should be give me that. Okay. There's so much going on here that needs work. Okay. CD, let's just do CCC. C, 4 C's. Okay, those should be 1, 2, 3 the same. Okay, because C to C to C to C. Okay, and this is going to fail. Okay, so I can say if note 1, see, I should have stuck with my original. If note 1 is less, return U. Else return R. Okay, and that's it's not complete, but it should work. And then I don't feel bad if I said else return question mark. You know, kind of splitting out these. Okay, if note 1 equals note 2, and if it's not equal or less, it must be greater. I'm going to figure these out. Why is that launching? I really don't know. Okay. Let's just run this. Okay. And we have okay, and test let's say 3 notes going down. Okay, and so G, E, C. We should get start DD. All right, in this case, this is D. Okay. And that should work. All right, and now let's grab something complicated. Oh, we can't do anything with that yet. Let's just grab this stretch. Filter out the stuff that we know we can't handle. Notes going up and down. Okay, we're going to analyze this string. Since we filter it, okay, we don't handle anything but capital letters. Oh, actually, that's even going to demonstrate that we're messed up. A is higher than C, so joke's on me. Okay, So I would like to be B to G is a down, G to A is an up, A to B is an up, back to A is a down, back to G is a down, F is down, D is down, E is up, F is up, G is up, B is up. Okay, this test is gonna fail. And it's gonna fail because notes don't work like letters. Okay, star UD, so it says we should go up B to G. B is less than G by the alphabet. Okay. We're going to have to map these things. Don't want to do this here. All right, I'll do it, and then we're going to extract out and get notes going. All right, so let's see. Let's let numbers equal notes.map, and we're going to take each letter in. All right. Now here's where it gets a little goofy. Let's say MIDI note numbers. I think I can just use these. All right, so 127 is the highest. I think 64 is middle C. Nope, 60 is middle C. Okay, so I want to translate them all to MIDI notes. Just, it's convenient enough. I'm pretty sure the range is going to allow it. And we'll go from there. Okay, now let's see. Where's the MIDI numbers? Key number, organ, piano, MIDI number. Okay. Oh, I didn't know they numbered them standard in pianos. Okay, 88. All right, so the lowest note MIDI can do is lower than the bottom note on a piano. I guess that's a standard piano. I don't know if Bosendorfer's run down a little the rest of the octave or something. I don't know. Maybe it goes down as low as a Bosendorfer. The frequency is pretty low if you're talking 8 hertz. Okay. Anyway, we'll take 60. A bit of an odd choice, but okay, middle C. It's not really in the middle in MIDI. I'm just going to map things to that. Okay, so if the letter is A or B, return, well, it's going to be 60 plus, I don't know if I can, how I subtract letters. Character dot. I think there'd be something to do this. Get bytes is kind of okay. No. You think I could get an integer number that represents a character, wouldn't you? What's coding key? Thank you. Okay, let's try some help. Get numeric value of character. That's not going to be quite right. Good grief. Okay. The worst is I know I'm not going to have anything but simple ASCII characters here. 21-bit number for a character or modifier. Okay. Let's try encoding of a character. I guess I got to go to UTF-8. No, that one. Okay, let's try this. Letter.utf8 dot raw value. I don't know. I think that's going to be an array. UTF-8. Right. I know it's only 1 byte. Okay. Let's take that. Oh yeah. I'm just trying to get through my test. Okay, if it's A, it's let's go simpler. Switch letter. We have a MIDI chart that tells us the answer. A natural is 69. B71 default. Now I can return 60 plus string dot of letter dot UTF-8 dot. Is that raw value sub-0? Oh, it's not even that, is it? Ugh. I think maybe I should just do these all cases. C is 60. D is 62. E is 64. F is 65. G is 67. Okay. Notice the one from E to F only goes up by 1. That's just like on a piano where you have some white keys with no black key between them. Then there's a gap between E and F, and there's a gap between B and C, which we'll get to see later. And default, I guess I'm going to return a 0. It's kind of a shouldn't happen thing. But if you get a really low note, you'll know. Okay. Now, number, okay, what is this? Letter. Hint. Numbers was never used. Okay, now let's do this. Numbers and numbers. We're still comparing less than or whatever. Okay. And I think this should make this pass. If I calculated it right. B down to, okay, I did. All right. Handle any uppercase letter. Okay. I think we've gone as far as we should here without bringing in the real notes class. Already we know this stuff is completely nothing to do with the up-down thing. Comparing them, that's legit. But knowing their encoding, that's really not good. Okay. All right. So I think we want to extract notes. Let's do that. Let's just do an empty class for now. Class notes. And it's got a constructor. Notes string. Okay. And then what else have we promised? Well, we've promised oh, gotta take this one out. Okay. We've certainly promised a map, and we've promised that it can access the letter. Okay. I want to encapsulate it, but let's start there. Well, what's this? This is let's say we've made notes. Okay, let's just keep a string for the moment of our notes of string. Okay, and self dot notes equals notes. Okay, and if you ask me for the numbers for, well, even that is not really what I want. Let's do it for starters. Okay, numbers for that returns an array of int, and the code is this. We'll extract this out. Okay, so if you say notes.numbers for, if you say notes.numbers for, you're going to get this stuff. So we should be able to say let numbers equal notes.numbers for. That should take care of this. Notice my type is still revealed, but this is progress. Okay. And then I think, well, that I really want to compare. I really want notes. Individual notes. So I want this to be an array of notes. Okay, so let's pull our same trick. Type alias note equals int. All right, let's see if we can nudge this towards a better implementation. Note. Okay, and that should work. Okay, and so extract notes class and note type alias. All right, so this thing, if it had the notes, well, let's flip this around. Let's make the numbers be what it holds. I'm going to pass this string in. That's okay there. Now down here, let's do this for the moment. Numbers equals notes dot numbers for string value of type notes. Oh, that's notes. Let's use notes.notes for a moment. We'll get out of this, but oh, analyze passes in notes. Okay, let's. I don't know if I can call it notes when I've already done this. Well, I can just, yeah, I can call notes.notes. Numbers. Let's just take notes.notes. Okay, so I'm converting it here. Let's make this private. Have I completely converted this thing? So notes, give me the individual notes and do the stuff. No. Self-used. Okay, let's make it private. Static. And move it to the end of the constructor. I think this will be okay. You can't call, if you want to call a function on your object, you can't call it until in the defer clause. Okay, our tests are passing though. Okay, let's commit this. Create numbers for, make that used in constructor. Okay. Good. It's still kind of ugly, but this part seems okay to me. As long as we have a string constructor, which we will for a while, we're getting the right thing. The Parsons code. Let's call this. Let's call it individual notes. Okay, and of course that should work. Okay, I think we're at a good stopping point for a break. We've gone a while. I'll extract these things into their own files, and then we have some work to do on notes for sure. This one, I'm not quite sure. It might be better off getting the notes. I don't know, the array of notes, maybe. Hard to know if that's the is that the real thing we're trying to find out. I think it might be. A bunch of notes. I don't know. We could call it a phrase, or sometimes it's called a sequence. There's other terms for it. I mean, I want it to be able to be a song, so it really is a bunch of notes. But when we look at it from an analytical point of view, I don't know. Maybe we really do want an array of notes, just as the result. Maybe it should be sequence of notes. That might be better. Okay, we'll ponder that when we get back. So 3-minute break and pick up from there. Thanks. All right, welcome back. Okay, so let's get this stuff cleaned up a little. I put us back in light mode. I know some of you hate that. Okay. So shared, I guess that would qualify. Let's do a new file, Parsons code. Whoops. I moved it down here for now. Okay. Parsons code, we need notes. Okay, make sure our tests work. Build failed. Parsons code allocation. Let's do a clean. Wow, undefined symbol.
Testable import tunesim. If I do a build, that succeeded. Testable import tunesim, that should be pulling in this. Notes test. Import tunesim, that's the project. The Parsons code. I don't think I need to say public. Oh, this is so annoying. Undefined symbol tunesim.parsons code. Clean build folder. Build. Run. Ah. tunesim.notes allocating. I don't know. It's like it's not finding the shared files. Implicit closure number 1 throws. tunesim.notes. Let's run it. That's okay. Oh, okay. Test Mac OS. Let's go back to the project. Test Mac OS. Should be a way to see what they see. Target application tunesim Mac OS. Yes, that's right. Debug release. Yeah, that's all okay. Dependencies. That doesn't depend on anything. Test Mac OS. Build phases. Dependency 1 item. That's right. tunesim Mac OS. Has these 4 sources. I don't think the folder grouping matters. If I put it back up here, let's run. No, same deal. Yep. Okay. I'm so puzzled. I don't know if I've just screwed up my test packaging so badly or what's going on. So it can't find this. Class Parsons code declared in Parsons code.swift. It knows how to find that. Should know how to find this. Yes. Well, it's got to be something with this, right? Target application, okay. Yep. Resource tags, I don't think that's relevant. Build settings. I mean, it should reference tunesim Mac OS somewhere. Dependency one item tunesim Mac OS. That seems legit. I mean, if I do this, I would expect problems. Yeah, can't find in scope. But if I take it out, undefined type metadata accessor for tunesim.parsons code. This is too much to read. All right, I don't want to be stuck forever on this. Let me pull these back in to here. See if they can find it here. Okay, I'm gonna have to. I don't know. I'm gonna have to do some research. I don't want to make you watch me do that. Okay. So the Parsons code, I think we're closing in on that. I think it needs to be. It's almost like it needs to be a sequence of note. Maybe this notes class is just a premature thing. But I do note, I mean, when you're in this analytical mode, you're ignoring rests and note durations and stuff like that. You really are after the individual notes in the song. No gaps, no nothing, just those. And so maybe that's the abstraction we want here. It's really Mike Hill's been having a good rant lately about wrapping your types as you go, and I think most of the time that's correct. But I kind of wonder in this case, I think you really are saying I really want to know the sequence of notes, and the whole song may be a much more complicated entity, but I'm just saying, like, give me the notes. And I could ask, give me the notes in measure one, or give me the notes in the first line, or other queries. But for the purposes of this kind of analysis, it really is, I just want to know the notes. And maybe that is what this is. So I think maybe this is a song, and you're just asking for the note sequence. Let's try that. So I'm going to say public note sequence function. Note sequence, and it gives you a sequence of note. I think I can say it like this. Sequence is a little funny. Okay. And then I think if you just return notes, you might get that. Okay. That's okay. I'm gonna have to look up how to do this. There's something funny about the sequences and how they return. Custom sequence Swift. Now, I would have thought array would conform to sequence. Array Swift. I guess Swift doc is okay. Okay, it is a sequence. Maybe I just have to be explicit here. Conforming to sequence, okay. To add sequence, add a make iterator method that returns iterator if you type. Oops, sorry. If you can act as your own iterator. Add a make iterator. Declaring conforms to both sequence and iterator protocol are sufficient, which I think this does. No. Huh, really? Indexing iterator. Indexing iterator conforms to iterator protocol. Iterator's indirect indexer. It is a sequence. But it doesn't mention iterating protocol up here. Okay, where'd sequence go? Maybe I'll make notes conform to sequence and be done with it. Conform, make your conform, add a make iterator. Okay. If you connect as your own iterator protocol. I think I have to provide the next, right? No? Okay, so maybe we make this conform to mutating function next. Return the next thing or nil. Okay, we can do that. Too much work. I don't know. It seems like arrays should be iterable already. Where are we on sequence? He's got this iterator type. Collection. Collection inherits from sequence, so all right, so maybe I just had to be one. Does not conform. Thank you. All right. Do I have to declare all that stuff? Conformance to sequence. If you create a custom sequence, make sure you conform to collection. Sequence. Add a make iterator that returns an iterator. Okay, you think it would tell me to do that? Do I have to say type alias element equals note? returns an iterator. This looks like I'm getting worse, doesn't it? So it must be declared public because it matches. Okay, I think I can iterate over that. Do I have? Note is the internal type. Okay, let's sit here. Okay. Sequence needs iterator. I think. I think we know that. And one more subsequence has a default. Okay, I will take that. Right. Okay, and then note sequence cannot be that. Okay. Oh, I still don't do it. No. Okay. All right, now notes. Let's see what Parsons code. I want to say notes is a sequence. Does this all work? Okay, I think that works for now, but this should just be notes. That's what I want to do. Okay, now I can inline notes again. Okay, so we made notes a sequence. I don't think that's wrong, but I don't think it's ideal either. I don't know. Notes. Now, can I say sequence here? Maybe. No. Protocol sequence can only be used as a generic constraint. Okay. Let's see what we got. All right, so now notes is a sequence. That seems good. You give it the array of notes and it works off that. That's all right. Okay, the make iterator makes it a sequence because it makes an iterator over the array. All right, I'm okay. Now this is clearly note stuff. I think right, we're passing back the ints for those numbers, but we really want to pass back notes. So okay, let's extract another layer. Public class note. I don't know what it is, but it's got stuff. Okay. And initialize it with a note name is a string. Okay. And it's going to hold, I think it's going to hold the int value. I mean, I think this is the core of it. Okay, so I think this let note value of int, and then note name of string. I think it's going to be a string. Let's switch note name sub 0 for now. And shoot, what can I do? Use an index instead. Oh, start index. Is that? No. Let's do that for now. First, case A. Why is nil the only value? Okay, so when you give me the note's name as a string, which I think is good, I give you the note value. I'm going to make I think this value is private. Okay, but I need an operator. I need less than equals. Cannot convert a number of int to return type note. Okay, yeah. So let's. Okay, to get moving, I think let's make it not private for a moment. Okay, and then this number 4. I think this is. That's used here. Okay, numbers 4. Let's rename this to notes of. Okay, so you give me a note string. I guess I'm going to map it. Notes.map and assign that or return that, I guess. Yeah, that'll work. Map each character into the note. So we're going to return note of $0. Type character string element character to impact it. Okay. Let's make this a string. Okay. That is that. Okay, I can inline this. Okay, and I don't need the function anymore. Right, so we're pushing the note creation down there. Type notes does not conform to sequence. Oh wait, what's the matter? String.iterator to return type note.iterator. String. Iterator. Non-local scope. Does not conform. Add stubs. Sure. What's the stub? Array note of iterator. Okay. Notes does not conform. Make sequence. Wait, expected this. What's off? Defer notes. Yeah, something's off. String. Whoops. Okay, should work. Yeah. Oh, yeah, less than and equal. Okay, yes, I need these on my notes. All right, that's what I wanted it to tell me. Back when. Okay, so on note, what is it? Public func operator less than. Oh. No one. Am I supposed to put this outside? I mean, I just did these in the parser. You'd think I'd remember. I think they go outside the class. Oh, that shouldn't be seen that. Function. Yeah, I think I'm close. Yeah. Okay. Was it complaining about equals? Yeah. Do I just say less? Non-void return. Oh, returns. Oh. Okay, we extracted note class. Okay, now this belongs in its own file. Class note gets internal value. I'm going to make this private. Is that going to work? Sorry, let's get that working and then deal with it. Did I put it up here? Yes, I did. Don't know what's going on there. Okay. Okay. Notes test. Nice notes. Okay. I think that part looks all right. Parsons code takes notes. Which is really a sequence of note. Do we say that? Well, yeah, I guess element equals note. Okay. And I don't think I need this defer anymore. Okay. Okay, so the note class, sorry, the notes is a sequence. I think that is legit. Now these, analyze should take a sequence of notes. Yes, that makes sense to me. It doesn't need to know more. Okay. And then I think let's look at note. Okay, let's look at notes. I think we're okay with that one. It's just the wrapper for a sequence of notes. And now the note class. This is awkward, but it's kind of All right. So I think what we're saying right now is letter notes, uppercase letters A through G, know their note value. We've sort of arbitrarily used MIDI note numbering. Otherwise, we would just pick something, and I think this is as good as anything for that. but our lowercase letters need to map to the next octave. Um, okay. And that tells me it's time for a test here. Let's do a note test. It didn't really do right by us. Note tests. Okay. Now what we want to know, I guess if you give me A through G, I want to know that each one of those gets the right MIDI value. Well, I guess I also want to know I want to know C is less than D is less than E less than F less than G less than A less than B, and vice versa. Do I care about note values? That's the question I have. I'm almost tempted to make this a MIDI. What do they call it in here? MIDI note number, which I think is the normal term for it. And I feel like I don't know if I need to wrap this or not. Okay. That I think I can give it a getter without a setter. Well, I guess it doesn't have a setter anyway. Okay. Let's make assertions on these. Test MIDI note number is correct. And then I'm just going to do kind of a helper. Check C should be 60. E, F, G, H, D, C. Okay, and then let's give the check function. Check takes a note string and expected in the MIDI note value, note number. Okay, and let's rename this to check MIDI node number. Okay, and let's take these numbers from the chart. So C is 60, 62, 64, 65. G is 67, 69, 71. Okay, and I believe these tests should all pass. Okay, and the next, let's split this up. Um, is correct. This is for uppercase. Let's do for lowercase. I'm gonna take this out, and then for non-note letters. Okay, we'll just keep the X. I don't think. Maybe H. Just check out a range there. Okay. And this, well, for now that should be all correct. Okay. Split test. Then let's go to the next octave. So C, D, E, F, G, A, B, and we're going to drop the non one. Okay. And C, next octave up, 60 is 72. 12 notes in an octave. Okay. So we should add 12 to all our values. All right. And notice again, capital B to lowercase c is a half step because B to C on a piano is half a step, no black key between them. All right, run this. Should fail, right? We don't handle any of those. Note. Should have refactored first, but B71. So yeah, I was at, this should be 72, 74, 76, 77, 79, 81, 83. Okay. I think I got all those right. Okay. Support lowercase note names. And I think I would just like to make a map out of this. So private let note to MIDI of type string to MIDI note number is What's my replace? Okay. Given note to MIDI, otherwise 0. Nope. Nil is the only value permitted in, oops. Character. Well, we did have string around this before, I guess. This may... we'll be revising this again. Getting the note names is actually a little tricky. Okay. So right now we have note test. Okay, uppercase, lowercase, empty, and a helper. All right. In our note class, you passed in a string. It has the note value, and then it offers comparison operators. And that is pretty much all it should do. Notice we're just using the comparisons here. I think we're okay. Parsons code looks right to me. Notes is a sequence. Now where they come from, that's going to be another challenge, but this is good. A little awkward. Mapping a list of note names to notes. I don't think we're going to need that in the end, but for now it's what we want. Okay, MIDI note number, I don't think, again, you'll need that for most purposes. If you wanted to play a song, and you'd probably need these MIDI note numbers. But for now, they're just convenient places to put these values. Okay. Let's see. Where's the next best place to go? I think our Parsons code deserves another test now, just to make sure it's mixing up upper and lower case properly. But it's not. This is uppercase only, and let's make another one that's like mixed. I'll say multiple octaves. This is 1 octave only. Okay. And again, I'm going to go take a stretch of these notes. Okay, here's a nice little blob. Well, DEDB. Yeah, how about this chunk? Yeah, that's enough to get a look. Take out these characters. Okay. And, okay, so D goes up to G, goes down to D again, goes down to C, up to E, down to C, and down to A. And I believe this is going to work if we've got our MIDI notes, right? Yeah. Okay. Let's see. What did we do in this? Note. I guess it really was the test. I'm just going to check these in. Not sure if that's quite proper, but oh well. So check that Parsons code works for notes in multiple octaves. Multiple octaves. Okay. So I think where we are at this point, if somebody gave us just the names of the notes, you know, they stripped out the bars and the numeric stuff and the colons, I think we could properly do this thing. Okay, everything's in a range. Now there is some interaction here. So the implicit side of this is when you put the pound sign, the sharp, at the front of the piece like this, you're saying every time you see an F, it should be treated as an F sharp, including different octaves. So that's an F, but the first bottommost space is an F to F sharp as well. So this is really D, E, F sharp, G, B, and so on. I don't see an upper F sharp. Oh, there's one. Yeah. D, E, F sharp, D, E, F sharp, an octave higher. Both those are really F sharps. Same thing here. Where was it? Thought I saw another one. Oh, yeah, there it is. There is another F sharp. Okay. So just knowing this stream of notes without knowing the key is not going to tell you the right notes. And I'm... Now, if you don't have accidentals, if you don't cancel it, then it all works out as far as the Parsons code is concerned, because Parsons code just deals with direction, and F or F sharp are both above E and below G, so they're okay. But I want to push more. Now I want to push more on the ABC notation, and I don't know. This is 112 pages, I think. Let's pull this tab out. Okay, so the ABC standard is, I mean, this is all the other fields, not down to the notes. Okay, so here's pitch. Okay, the letters are used. And then notice we get C prime, D prime, and G comma, A comma. So you can indicate the octave with commas or primes. And actually, I think you get, yeah, you can have multiple commas. Okay, each one lowers the note by an octave. And, or raise it, quote, ticks raise it an octave. Okay. And you can also use fields to say what octave we're in. The English names C through B, C, D, F, G, A, B, correspond to Do through C. Okay, yeah, that's all true. All right, and then symbols, less circumflex, equals, and underscore are used before a note to indicate sharps, flats, double flats. They don't say anything about triple flats or triple sharps, which some people might use, but it's really bizarre if you do. I mean, it's one thing to be in the key of G flat, and it's another thing to be in the key of G flat, flat, flat. Okay. So from this, I know that if we have our note should be of the form less than equals or underscore. Well, it's either sorry, arrow, arrow, arrow equals underscore, underscore, underscore can be in front, and as many commas as we can stand or ticks as we can stand in back. And I'm okay to put a limit on them, like we're not going to go below the MIDI notes, and so on. Same thing down here when you get to note lengths. We want to handle 128th notes. Well, I mean, I've seen a piece of music with that, but I've never played a piece of music with that. Like, oh, look, 128th notes. Usually we're using quarter notes, so quite a bit bigger. Okay, so I think let's nudge. What should we do? One thing would be to nudge our note stuff to handle octaves. Okay, so let's put things in to-dos. Parsons code for a simple string. I think we've done it. This is TUNE-22-01, September 12th, 2022. Okay. We've done this. That's great. Okay. Another thing we could do would be make note understand comma or tick for an octave down or up. We could make note understand arrow, arrow equals underscore or underscore for sharp, 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 natural, flat, or flat, flat. Okay. And if we did that, we would have completed section 4.1 and 4.2. Mostly. Okay. And we can follow them by numbers. I guess we've not dealt with note lengths, so we will have dealt with this much of our 112 page standard. Okay. And I think that's where we want to go. I'm of two minds about the ABC stuff. One is, I think most of it is not something we're going to need for the analysis we're doing. And yet, I think if I default to it, I mean, I do want to be able to read ABC tunes right out of a website or a file and analyze them. So I think working on this note stuff will do is it'll get us closer to being able to say, just hand me this string, this arbitrary string. It basically says whatever follows the K colon until the next X colon or something like that is going to be the notes in the thing. I would like to take arbitrary strings like this, feed it in, and run a Parsons analysis. And Parsons analysis can ignore the bracket 3 and the bar lines and the spaces and everything implied by those, as long as it spits out these notes, upper, lower, commas, whatever, and understands sharps and flats and so on. That would be a step towards reading a full file and doing it. And I think honestly, if there's the tune, T is the tune title. I guess the index and the tune title are both moderately interesting. The key we're going to need, the length we're going to need. I don't think this is, CI, I guess that's the common with, or C bar, it's the common with the common meter like that. We might need the meter, the length, and the key. I mean, we'll need some of these fields to do stuff with, for sure. Not all of them. But I think if we get to the point of parsing some of them, we can parse the others and ignore it, which is fine for us. We need to, we don't care we don't care who transcribed it. We're trying to figure out, do these songs match? So who transcribed it is, important for the provenance of the song, but it's not important for us in the analysis of the song. Okay, we just have a few minutes left. Let's see. What's my best way to do this? Well, the prefixes tell you in principle. Okay, let's take the key of G as 1 sharp, and if you see an F, it's implicitly F sharp. If you passed in equals F in the key of G, it should come back as an F natural, half a note below the F sharp. And so there's sort of an implicit thing, like who's going to know the key? I could, should the note understand the key? This is one of these puzzles I don't really know the answers for, because it's kind of ambiguous where the right place is to know these things. The key can change in the middle of a song, is another challenge we have. I could be playing in D and then switch to the key of G, and then all of a sudden the notes I have that were written with F, C is sharp in the key of D, so F sharp was there already. C now, goes from sharp to flat, or sharp to natural, or natural to sharp, depending on G or C, G or D key. So I guess if I knew the key, but the problem is the key is a heck of a thing too. Let's find the information on that. Well, let's just search for key. Key. Okay, this will tell us something. Yeah. Okay, so in normal Western music, kind of like the stuff you learn in piano the first 3 or 4 years, okay, everything has either 0, 1, 2, 3, goes up to 7 sharps, or 0, 1, 2, 3, 7 flats. By the time you get down to 7 flats, C flat is actually the same note as B. So the circle kind of wraps around that, 8 flats would be one fewer, would probably be E, I guess. Okay, and so on, down through. Like, notice G flat and F sharp are actually the same note, kind of, and C sharp and D flat. So as you wrap around, you keep going. But normally you only see 0 through 7. And then within there, you have the keys. So key of C is no flats or sharps. G is 1 sharp. D is 2 sharps, and so on. Okay. And then you have corresponding keys. They're called modes. And if you start your scale on C and you play the 7 notes with no sharps or flats, you get a C scale. If you happen to start on A, you get an A minor scale. If you started on G, you get a G Mixolydian scale, and so on through all these 7 modes. 1, 2, 3, 4, 5, 6, 7. Yeah. Basically corresponding to starting on whichever note. Okay. And that's 7 times 15, like 100 something combinations, right? 105 combinations. But you're allowed to do even crazier things. So you can put something in the key of D Phrygian and add an F sharp, or a klezmer mode, D major with a flat C, a C natural. That's Mixolydian. Wait, Phrygian with an F sharp is a klezmer mode. 2 flats, 1 sharp. Okay, you never see that in Bach, as far as I know. 2 flats, D Phrygian, and add a sharp to it. So There are a lot of possible keys. I mean, I guess you could take any one of these 105 combinations and do something, some other thing to it. Okay. Add these accidental notes. There can be several modifying accidentals, each one followed by a note letter. And I suppose you could probably do, and you could say EXP for explicit. Okay. So, I mean, saying what the key is a job in itself. Okay. I don't know what to do. So one choice is the key is outside the note, and whoever is going to create the real note has to take into account the key. And maybe this is okay. Maybe that's a good thing. Like, I don't know. If I give you an F and I gave you the key, you would say, oh, key of G, well, F is the 1 sharp, so that F should be implicitly F sharp. Okay. And if I gave you in something D Phrygian with a sharp F and I gave you an F, you would say, oh, it's an F sharp. If I gave you an E, you would say, oh, it's an E flat because it's 2 flats. Okay. Yeah. So if I almost feel like we ought to give you the note. Like if I gave you a C natural in and in the key of G, where F sharp is the sharp, it should say no. That's still an F natural. Okay. So gosh. And so what I'm worried about is like the raw. Someone says there's an F, like this one right here. In the code here, this is an F, DEF, like this one, DEF. And we should say that's an F sharp given the key. But somebody's going to say it's an F sharp, and so that is MIDI note, whatever it is. Let's go find it. F sharp is going to be 66, right? So somehow when somebody asks for what's the note for F, it turns into F sharp and we say 66. So I think I'm going to say, let's do the modifiers and the sharps and flats and all that stuff in here, but then there's going to be another stage that says map from the tune to the notes is going to have to know the key at that moment. Okay. Well, that's a handful we've done for today. I've still got something going on with these tests and the test, like I don't have a proper, whatever this is called, test scheme or something. I may do that on my own. We may just like take 15 minutes at a time until we get something right. But I think we made progress that, like Parsons code, if you stripped out all the non-letters in an ABC notation file and fed it in, our Parsons code would actually compute the Parsons code, ignoring repeats and stuff. But it would do something, and something reasonable, and I could feed in all the versions of Speed the Plow and get contours for them in the UDR form, and that's progress. So I'm happy to start there. Next time we'll focus on keys, and if I haven't cleaned up this test problem, we'll probably do some work on that. Next time we'll focus first on getting the notes with sharps, flats, accidentals, and octaves, and then we'll worry about the keys and how all that stuff goes. It's
it's quite a thing. I mean, all the possibilities here. And again, this is like one paragraph, one table out of, a huge file description. So, these ABC files have grown into pretty monstrous sized things. Okay. But thanks for joining me today, and I hope to see you again in the future. Have a good evening and take care. Bye bye.